Currying. Function currying is a specific kind of function transformation where we translate a single function that accepts multiple arguments into multiple functions that each accept a single argument. This is a normal 3-argument function, box volume 3, 4, 5. This is a curried series of functions that does the same thing, box volume 3, 4, 5. Here's another example that includes the implementations: def sum a b, return a plus b, print sum 1, 2, prints 3, and the same thing curried: def sum a, def inner sum b, return a plus b, return inner sum, print sum 1, 2, prints 3. The sum function only takes a single input a. It returns a new function that takes a single input b. This new function, when called with a value for b, will return the sum of a and b. We'll talk later about why this is useful. Assignment. In Doc2Doc, depending on the type of text file we're working with, we sometimes need to transform the font size of the text when it comes time to render it on the screen. Fix the converted font size function. We are using a third-party code library that expects our function to be a curried series of functions that each take a single argument. Converted font size should just take a single argument, font size, and return a function that takes a single argument, doc type. That function should return the font size multiplied by the appropriate value for the given doc type. Tip: you can always reset the code to see the proper font size multipliers if you accidentally change them. Why curry? It's fairly obvious that def sum AB, return A plus B is simpler than def sum A, def inner sum B, return A plus B, return inner sum. So why would we ever want to do the more complicated thing? Well, currying is often used to change a function's signature to make it conform to a specific shape. For example, def colorize converter doc, converter doc. The colorize function accepts a function called converter as input, and at some point during its execution, it calls converter with a single argument. That means that it expects converter to accept exactly one argument. So, if I have a conversion function like this, def markdown to HTML doc asterisk style, I can't pass markdown to HTML to colorize because markdown to HTML wants two arguments. To solve this problem, I can curry markdown to HTML into a function that takes a single argument. Def markdown to HTML asterisk style, def asterisk MD to HTML, doc. Do stuff with doc and asterisk style. Return asterisk MD to HTML. Markdown to HTML italic equals markdown to HTML italic. Colorize markdown to HTML doc. Currying practice. Remember, currying is when we take a function that accepts multiple arguments. Final volume equals box volume 345, print final volume, and convert it into a series of functions that each accept a single argument. Final volume equals box volume 345, print volume. Box volume 3 returns a new function that accepts a single integer and returns a new function box volume 3, 4, returns another new function that accepts a single integer and returns a new function box volume 3, 4, 5, returns the final result. Here's another way of calling it, where each function is stored in a variable before being called. With length 3 equals box volume 3, with len 3 width 4 equals with length 3 4. Final volume equals with len 3 width 4 5. Print final volume. Here are the function definitions. Def box volume length, def box volume with len width, def box volume with len width height, return length width height, return box volume with len width, return box volume with len assignment. Doc2Doc needs to be able to find the number of lines in a document that contain a specific sequence of characters. For example, given the following document, EBBB, CCDDABB, how many lines contain the sequence R? The answer is 2, and AABB. Complete the lines with sequence function. It should return a series of curried functions, so it can be called like this. NumLines equals lines with sequence, char, length, doc. The sequence is generated by the first with char that has been provided for you. It works like this: character, length, sequence. A, 3, R, B, 2, BB, 4. You need to define and return a second curried function. I called mine with length. It should accept the final parameter, a doc string, and return the number of lines that contain the sequence. Define the with-length function inside the with-char function. HTML table. Doc2Doc should have tools to create HTML boilerplate. One of the features should create a table. An HTML table has a header row and data rows. A header row has headers for the columns. Each normal row has data cells which contain the information in the table. It is essentially a two-dimensional list. Example HTML table. Table, row 1, header 1, row 1, TD row 2, cell 1, row 2, cell 2, row 3, cell 1, row 3, cell 2D. Each item in a table goes in its own data cell, which are arranged in rows. The table row tag goes around each row of cells. The header cells hold the headers for each column and belong in the first row. Table. This is the parent tag of the entire table. Result. Row 1, header 1, row 1, header 2. Row 2, cell 1, row 2, cell 2, row 3, cell 1, row 3, cell 2, assignment. Complete the create HTML table function. It takes a list of lists of strings, data rows, and returns a function, create table headers. Create table headers should take a list of strings, headers, and convert them into the header row of the table, then return the complete HTML table as a string without any added whitespace or indentation. Use the provided functions to complete the create HTML table function. Within the create table headers function, Markdown image. Markdown makes displaying images as simple as possible. To add an image to a Markdown document, just use this syntax. Alt text, a brief description for screen readers and web scrapers. Required for accessibility. URL or relative path to image. Title shown on mouse hover. Optional assignment. Doc2Doc makes using Markdown a breeze. This includes adding images to Markdown documents. Complete the Create Markdown Image function using currying. It takes a string input, alt text, and returns an inner function. It should enclose the alt text in square brackets prefixed with an exclamation point, alt text. Create the inner function returned by Create Markdown Image. It also takes a string input, URL, and returns an innermost function. The inner function should first escape any parentheses in the URL by replacing them with encoded sequences. Use the .replace string method to change any opening parentheses into cent28. Do the same to change any closing parentheses into cent29. Enclose the URL with parentheses URL. Add the enclosed URL to the end of the enclosed alt text. Create the innermost function returned by the inner function. It should take an optional string input for the title. If a title is passed, enclose it in double quotes. Then add the quoted title to the image syntax by first removing the closing parentheses from the end of the image syntax. Add a space and the quoted title with a closing parenthesis to the end of the image syntax. Return the finished image syntax.
check the toilets on the right?
Did you check the toilets on the left?
Did you check the toilets on the left?
Did you check the toilets on the right?
Did you check the toilets on the right?
Did you check the toilets on the left?
Did you check the toilets on the left?
Okay, you win.
Ribbit, I can't hold it. Last toilet with me have me already sold it. In the rain or in the snow, I got the funky flow, but now I really got to go.
In the rain or in the snow, you got that funky flow, but now you really gotta go.
The toilet over there will bring you luck, so give up, I got no time to spare.
The toilet over there will bring you luck, so give up, I got no time to spare.
In the rain or in the snow, I got the funky flow, but now I really got to go.
In the rain or in the snow, you got the funky flow, but now you really gotta go.
The toilet over there will bring you luck, so give up, I got no time to spare.
The toilet over there will bring you luck, so give up, I got no time to spare.
I'm losing up, I'm out of here.
Walk the walk, even if you can't just talk the talk. I got a call. I am a chicken from the kitchen, and I ain't kidding, although nothing is written.
You are a chicken from the kitchen, and you ain't kidding, although nothing is written.
Crack, break, fix the door, you know. I gotta go, so yes, open up, you know.
Crack, break, fix the door, you know. I gotta go, so yes, open up, you know.
I am a chicken from the kitchen, and I ain't kidding, although nothing is written.
You are a chicken from the kitchen, and you ain't kidding, although nothing is written.
Crack, break, fix the door, you know. I gotta go, so yes, open up, you know.
Crack, break, fix the door, you know. I gotta go, so yes, open up, you know.
It's all yours.
This is life.
Check. Oh my god, there's a microphone. My wife just informed me that I didn't have the microphone going. Welcome to functional programming in Python. Why Python? Because that's the language that I've learned initially with Boot.Dev. So image syntax, list -1 from the end. So we're removing that trailing parentheses and adding in the title in the F string. Okay. Add a space. Then add the quoted title to the image syntax by first removing the parentheses from the end of the image syntax, yeah. Add a space and the quoted title with a closing parentheses to the end of the image syntax. So we're cutting off that last parentheses, and then we're putting in our title with a parentheses at the end. So can I just do it like this? Turn the image syntax. Invalid syntax. Take a string as input. Turn an inner function. It should enclose the alt text in the square brackets, preferred with exclamation point. Create the inner function. Add the enclosed URL to the end of enclosed alt text. mean, description for screen readers, that's a string. Okay, so alt text in the URL, that's a string. So does this need to be a string? Assuming image syntax is a string. It's supposed to be a string. I don't know. It's supposed to be a string. But we want the URL to be the inputted URL. Right, so we want these to be wigglies. That, right? Trace back. Okay, markdown image locals A and B, missing one required positional argument title. Might be a title. So is it just if title equals nothing? Like a blank string? Missing one required positional argument. Boots, help me out, brother. Let me change this back. In your image syntax, you're using a literal alt text instead of the alt text parameter. Oh. The inner function B needs to be handled the title correctly. When the title is provided, you're using an else if with a condition that doesn't make sense. Oh, I have to set this probably equal to something. I'm probably forming a title with quotes. Innermost function should work with an optional parameter. The return logic in your innermost function doesn't correctly handle the title case, right? What do you think the innermost function should return in the title provided? According to the instruction, what should the final form look like? The syntax error in your code. You're using an assignment with a conditional, which isn't valid Python syntax. Your innermost function B, make a title parameter optional with a default value. So title equals like a default value. Handle the case when the title is provided correctly. Remember that the title should be enclosed in double quotes and added with a space before the clothing parentheses. According to the instructions, what should the final format look like when the title is provided? Should be something like, right? How would you modify your code accordingly to make the string correct? This title got to be equal to for a default value. None. Is it none or is it empty string? And it fucks up my logic though. Can't use the equal sign instead of else if. Let me make a guide through correcting this. Instead of using else if C, you should use make a variable outside the conditional. Turn that variable. Oh, it is title equals none. Format should be this, so it's this. Minus the last parentheses. Plus the F string. Space title. It's the title plus the ending parentheses because we're ripping the last parentheses off and then we're adding the title plus parentheses. But does this title need to have like quotes on it? Oh, I guess it does. So it has to look like this. So to get that, we need to do... Space. Alright, now it works. Title. Close parentheses. I feel like this is a convoluted way to do this. Like, I've done this before where it was like I don't know if it's like brute forcing it, but like I'm physically putting in the quotations and the parentheses at the end there. I mean, the bear's kind of trying to tell me to do that, so... Oh, you can do dot replace, huh? That's interesting. I didn't know you could do that. So they set a variable for the f string of the alt text. Oh, they did the same thing. Okay, so they did the same thing in the innermost function. It is like literally cutting off the last parentheses and then adding in the f string of the title and another parentheses. I just mushed this into not having a variable. The instructions on this one wasn't great. I had to fumble through this.
Resize image. Doc2Doc should include a feature for image resizing, allowing users to adjust image dimensions to specified ranges. This ensures that images in documents fit and aren't freakishly large or hilariously small. Assignment. Complete the new resizer function using currying. It takes integer inputs max width and max height and returns an inner function. The inner function should take optional integer inputs min width and min height with default values.
Okay. As soon as he starts the assignment, like I'm not listening. Start at the first step. Complete the new riser function using currying. It takes integer inputs max width, max height, and returns an inner function. Okay. The inner function should take optional integer inputs, minimum width and minimum height, with the default values of size. So call it minimum size, min size function. And the input is min width, and that's equal to 0. And min height, that's equal to 0. If min width is more than max width, or min height is more than max height, raise an exception. Alright. Min width is greater than max width, or min height is greater than max height. Raise exception. Minimum size cannot exceed maximum size. Okay. The innermost function should take 2 integer inputs, width and height, and return 2 integers. What we call this one? Takes 2 integers, width and height, and returns 2 integers. Oh, excuse me. Use the built-in min-max functions to reproduce and increase width and height as needed and return a new width and height. So this is like resize. Resizing. Call it resize. Width. Height. Beep, 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 beep. Use the built-in min-max functions to reduce or increase width and height as needed and return the new width and new height. Alright, so we have a new width. New height. Example. Our new razor function returns a set min size function. The set min size returns the resize function would look like this. Create the resizer maximum dimensions 800 by 600. Set the minimum dimensions 200 by 100. Resize the image. Output the results. Okay. Turn the smallest item in the iterable, the smallest of two arguments. Turn the largest. So it's going to try to figure out what the maximum is between width and minimum width. Computer size with the maximum dimensions. Set the minimum dimensions. Resize the image. We're comparing width to minimum width. And then whatever that value is, need to compare it to the maximum width. we need to compare width to minimum width. Using max and min. They can be arguments. Do we need a key? I don't think we need a key. Key can be none. So I think we want the max of the width and the minimum width. Right? And then we want to take the minimum of that value against the max width. Is this right? Or do I have this backwards? So the max is maximum between the min width and the width. I might have this backwards. Maybe I just need to write this out like logically. I'm getting caught up with max and min. So what I want to say is, like, if the width is smaller than the minimum width, set it to min width. Is that what I was doing? So, like, min width is 200. Or whatever. So it's going to take the maximum of these two values. So you can't go below 200. So min width will always be 200. So width can either be 200 or greater, right? With this max function. And then you take the minimum between that width and the max width. The max width, to say, is like 1,000. Can't go higher than 1,000. So if it goes above 1,000, the minimum would be the max width. But if it's below 1,000, it will be the max width, min width thing. Yeah, I think this is right. I think I wrote it out right. Right? I think I have to draw this. If I don't do, like, if statements. So I think what I want to say is so let's say min width is 100 and max is I don't know, 800. So we're finding the max between the width and the min width. So we want the max of, so let's say we have a 300 width image. So we want the max of 300 and the minimum, which is 100. So that would give us 300. And then we want the minimum value between 300 and the max width, which is 800. Right? So then this confines our parameters, right? So like if we take the max and one of the values is 100, if it goes below 1, it'll always stay above 100. And then if this is a given constant, same thing with this. So it will always stay below 800. Right. So that's what we want. We want the within the range of these. Okay, so this is right. And then I think height is the same exact thing, just with height values. Okay, that looks good. Turn new width and the new height. Turn resize. Return min size. Do 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 do. Two passed, one failed. Pass, pass, fail. Expected 800, 600, actual 800, 800. So the height's fucked up. Oh, I wrote width. There we go. They did min on the inside, so the minimum of the max height and then the maximum of the min height. Yeah, it's the same thing, it's just opposite ways to do it. Like mine's starting at the minimum height, where theirs is starting at the maximum height, but we're both going to each other's other extreme. So like, I'm starting at min, going to max, and they're starting at max, going to min. It's the same thing. It's checking both ways. Okay. Should make mine look nice too.
Decorators. Python decorators are just syntactic sugar for higher order functions. Example, def vowel counter func to decorate, vowel count equals 0. Def wrapper doc, non-local vowel count vowels equals AIU. For char in vowels, if vowel count equals 1, print f vowel count. Return func to decorate doc. Return wrapper at vowel counter. Def process doc, print document doc. Process doc what? Vowel count 1, document what? Process doc a wonderful. Vowel count 5, document a wonderful. Process doc world. Vowel count 6.
So it's a vowel counter. And then it's printing the inputted document as a string. Okay.
Document world. The at vowel counter line is decorating the process.doc function with the vowel counter function. Vowel counter is called once when process.doc is defined with the at syntax.
Right, so you're processing it through I'm lost here for a second. I'm process doc print document.
But the wrapper function that it returns is called every time process.doc is called. Document world. The at vowel counter line is decorating the process.doc function with the vowel counter function.
Okay.
Vowel counter is called once when process.doc is defined with the at syntax, but the wrapper function that it returns is called every time process.doc is called. That's why vowel count is preserved and printed after each time.
Oh, they're going into it, how it works here.
It's just syntactic sugar. Python decorators are just another, sometimes simpler, way of writing a higher order function. These two pieces of code are identical, with decorator. At vowel counter, def process doc, print f document doc, process doc, something wicked this way comes. Without decorator, def process doc, print document doc, process doc equals a vowel counter process. Process doc, something wicked this way comes. Assignment.
Process underscore doc. Kind of get it.
Provided file type aggregator function is intended to decorate other functions. It assumes that the function it decorates has exactly two positional arguments. Create a process.doc function that's decorated by file type aggregator. It should return the following string: f processing doc, file type, where doc and file type are its positional arguments. See line 11 for where it's being called.
I mean, is that just the string that we put in? Like you do like a process underscore thing? I'll have to look at it when I come back. I'll be back in a sec. frigid ass. Alright. Look, I gotta get my little what do you call it? Like ear warmers on. Create a process doc function. Alright. That's decorated by the file type aggregator. So doc and file type. Should return the following string. That? Well, I got doc and file type from here, but I guess I'm supposed to read it here. Function to decorate. Okay, so that's important. Process doc is not defined. What? Oh, we have to do the at. That's right. At me. File type aggregator. Still not defined. In process doc is not defined. Ah! Provide file type aggregator function is intended to decorate other functions. It assumes that function in it decorates has exactly two positional arguments, right? Doc and file type. Create a process doc function that's decorated by file type aggregator. That typo or something? String I copy pasted. Where doc and file type are positional arguments. See line 11. don't have to be like this indentation, right? Ah, shit. My indentations are wrong. I forgot this file type aggregator line too. Args and quargs. Can you buy Doom on Steam? Like OG Doom? I could probably just actually bootleg it, but... They have like Doom in browser. Oh my god, it's arrow movement. I forgot about this. Thanks. Shoes untied. What? Right? Oh, it's like one of those recyclable bowls. Good on them. Bad for me. Oh, it's hot. I need to turn the volume down on this though. No. Gotta go back. Fuck, I don't know the buttons. Why is it? I don't remember if there's a jump. I don't think there's a jump. Oh, shit, what the fuck? Oh, weird. The mouse... The controls are fucking crazy on this. Yeah, that fucking shotgun. Okay, I can't like turn. So sensitive. Ah! Eh? Oh, that's that one. Oh my god. The controls are like conflicting with themselves. Maybe I shouldn't play with the mouse. This is so slow though, playing like this. The mouse left and right was okay for like aiming, but when you fucking if you push forward on the mouse or back on the mouse, the dude would move back and forward. And then I was using WAS to like move back and forward. So if I hit W to move forward and I pulled the mouse back just like a little bit, it would cancel out the movement. So it was like fucking weird. Give me the full check to begin with. What lower did I? Did they hand out a dividend? It usually dips. How much is the dividend on this spot? I don't even know. Not even a percent. 170 for $560. Or it's well, 0.3%. Yeah, I mean, that's with the dividend. After the dividend handout, it usually drops. That's probably what that first step is. I don't know what this second step is, though. Something happened here. 8 a.m. Was what, 4 hours ago? On dimming outlook, Zax. Everybody thinks that Terraform is like terrible. I think it's moot. It's just because they want to disagree with the president. I don't think it's like anything. I think it's just like like a side grade, right? Like in a game. Instead of strength, getting vitality. If the Fed's gonna get the tariff money, right? But things are gonna cost more. But if the government gets more money, stocks will go up. But things will cost more. Inflation. Like real inflation of goods. The cut rates, I guess. They can't cut rates. Inflation keeps up. What was that? I shouldn't be looking at 1 minute chart anyways. A lot of selling volume. Just trying to look at the volume. It's COVID. Oh, this is at 250. Very soon. What's it called? Like graph? I don't want a graph. I want like a infographic. Not sales. I want like a bubble chart of like how many of the cars are out there. Sales volume. Oh, this is total. Give up growth. Top selling models: Ford, Tesla Model Y, Toyota RAV4, Chevrolet Silverado. Top selling brands: Toyota, Ford, GM, Honda, Hyundai. Ugh, Hyundai. Alright.
Args and quags. In Python, args and quags allow a function to accept and deal with a variable number of arguments. Args collects positional arguments into a tuple. Quargs collects keyword named arguments into a dictionary. Def print arguments args quargs. Print
Hold
f
on, I'm not listening.
args and quargs.
One second. Ah, fuck. All right. Args or quargs?
In Python, args and quargs allow a function to accept and deal with a variable number of arguments. Args collects positional arguments into a tuple. Quargs collects keyword named arguments into a dictionary. Def print arguments args quargs. Print f positional arguments args. Print keyword arguments quargs. Print arguments hello world a equal 1 b equals 2. Positional arguments hello world. Keyword arguments a 1 b 2. Positional arguments. Positional arguments are the ones you're already familiar with, where the order of the arguments matters. Like this, def sub a b, return a minus b equal 3, b equal 2. Res equals sub 3 2, res equals 1. Keyword arguments. Keyword arguments are passed in by name. Order does not matter. Like this, def sub a b, return a minus b, res equals sub b3 a equals 2, res equal mang is 1. Res equals sub a b equals 2, res equals 1. A note on ordering. Any positional arguments must come before keyword arguments. This will not work. Sub b equal 3 2 assignment. At doc2doc, we need better internal debugging tools. Complete the args logger function. It takes a variable number of positional and keyword arguments and prints them to the console. Print each positional argument score sequentially using numbers and periods as the prefixes, starting with 1. For example, args logger what's up doc prints to the console what's up doc. Print each keyword argument score alphabetically by key using asterisks as the prefix with a colon in between. For example, args logger there, age equals 17, date equals July 4th, 1776, prints to the console, hi there, 7 date July 4th, 1776. Use the sorted function to get the order right. Tips. Don't feel guilty about using loops. Quargs is a dictionary, not a list. My recommendation is to use the .items method to get its key value pairs as a list of tuples, then sort that list before printing.
Okay.
Ever want to leave? Anything that you desire? Set it on fire. I'll make a stand, your daddy's all away. That's my desire.
Need a better internal debugging tool is complete the args logger function. It takes a variable number of position and keyword arguments, prints them to console. Print each positional argument sequentially using the numbers and periods as prefixes, starting with 1 dot, for example. The tiny bowl of mac and cheese is perfect. I'm not that hungry, so. We want the value of args or we want the length of args? I think we want the length. Right? Yeah. Because we're going to be labeling them 1, 2, 3, 4. So it starts at 0 inclusively. So we need to do 1 plus. I essentially. Because 1 plus 0 would give us 1, you know, our first position or whatever. It's fucking chewy, man. Do you even cook these? It's a little al dente. Like I'm chewing gum. Al dente means to tooth. I couldn't get to tooth. Yeah. You gotta do it at least some fee fi full fum. The you gotta do the testing way, which is throwing it against the wall. If it sticks, it's ready. Okay, so we need to print whatever I is +1, so additional argument sequentially. F string of I +1. And then a period. And then print out the argument as well. for that I position. Okay. So we got the numbers printing. Print each keyword argument alphabetically by key using asterisks as a prefix with a colon in between. For example, so anything that comes from the dictionary needs to come out with an asterisk. I use sorted function to get the order right. Okay, so we need to sorted the dictionary quargs. Print each keyword argument. So we need the keys of quargs. The values. Corresponding value pairs to the keys. That sorts it. This is sorted. Keys. Gotta write another for loop. Gotta go over each one. Keyword and argument alphabetically using asterisk as a prefix with a colon. Okay, so for ion keys, sorted keys, print f string alphabetically using asterisks. Asterisks I right, that's the key, and then the value associated with it would be as a prefix and a colon in between, so colon. Then we need the value of quargs, so quargs I. Print each keyword argument alphabetically, so we sorted quargs dot keys. Those are our sorted keys. That's good. And for the I and sorted keys, f string asterisk with the key that's sorted, inputted key, colon, and then the value, the associated value, the input. Hey, does that work? Good riddance, date. Hello world. Oh, this is asterisk. Looks right. The numbers are ordered. The asterisks are returning keys and values. That's all I had to do? Okay. So they said I equal to 1. Oh, they made a counter for I. Right, so if it's the first input, it gets the value of 1. If it's the second input, it gets the value of 2. Well, normally it's 0 and then 1. Okay. So print input position starting at 1. And its associated argument. Okay, way different. For key value and sorted pairs, Quargs items. Because Quargs is a dictionary, right? They're key value pairs. Dictionary. Print. Bar, key, and value. Yeah, it's the same thing. I just use more variables. Okay.
Decorators. The args and quags syntax is great for decorators that are intended to work on functions with different signatures. Example: the log call count function below doesn't care about the number or type of the decorated function's func_to_decorate arguments. It just wants to count how many times the function is called. However, it still needs to pass any arguments through to the wrapped function. Def log call count func_to_decorate count equals 0. Def wrapper args quags non-local count equals 1, print called count times. The enshow syntax unpacks the arguments and passes them to the decorated function. Return func_to_decorate args quags. Return wrapper assignment. Complete the markdown to text decorator function. It can decorate a function with any number of string arguments.
The star and double star syntax unpacks the arguments and passes them to the decorated function. Complete the markdown to text decorator function. It can decorate a function with any number of string arguments, no matter if they're positioned or keyword arguments. It will run the decorated function, but first strip out any markdown heading symbols. See below for an explanation of markdown headings. It should return a wrapper function that takes .args and .quargs. The wrapper should map the args to a new list where each string is converted to plain text using convert.md to text. Map the args. To a new list where each string is converted to plain text using convert.md to text. Map is like function and then iteratable, right? So map, the function is convert MD to text, and the iteratable is args, star args. Map the args to a new list where each string is converted to a plain text using that. So then we list function this. Right? To a new list. So new args. I just call it A.
But without stiffness, and should feel comfortable. Don't ever let yourself become tense. Now let's type some more on
Map the quargs to new dictionary.
Where each value is converted to plain text.
Use the item dictionary to pass a list of tuples of key value pairs to the map. Items returns a new view of dictionary items key value pairs. So quargs.items. Create a function for map. Changes the value of an item in tuple.
using proper rhythm, wiggle your fingers and jam the keys. A quick snap of the fingers, and with practice, that's all there is to it. Using proper rhythm, wiggle your fingers and jam the keys.
So B is equal to, I'm assuming dict, the dictionary of this. I need to edit this corgs.items. So we have to convert the orgs into a list of tuples. The key value. And then apply map to it. So let's break it down a little bit. So for key value in orgs items, I don't know if I want to use a for loop. Shit. Map the corgs to a new dictionary where the value is converted to plain text using convert. Guess I could just write it like, I think I'm trying to take too many pieces at once here. Use .items dictionary method to pass a list of key and value pairs to the map. Create a function for map, which changes the value of the tuple to convert. Map the course to a dictionary where each value is converted to plain text. Converted text, the key should remain the same. Use the .items dictionary method to pass a list of tuples to pairs to the map. I'm a little stuck here. So, for key and value, let me continue this thought. In Korgs got items. Remember the values converted to plain text, and the key should remain the same. Use the items dictionary method to pass a list of tuples of key value pairs to the map. Create a function for map which changes the value of an item tuple. Return a resultant column decorated functions with new arguments. Take a look at the editor's format by file tab. See what formatted functions do. What arguments are they expecting? Use star tuple unpacking star dictionary unpacking operators to pass variables as correct arguments. The provided convert MD to text function takes a string markdown text and returns a string of text with any heading symbols removed. For example, this is a heading, this is also a heading, this is not a heading, this is also not a heading. mean, it's just, is it just like this? The above one? So we're gonna map orgs to a new dictionary using convert MD to text. Map the chords to new dictionary with a value is converted using plain text. Key should remain the same, so is it quargs.values? So we want the values, right? Use .items dictionary method to pass a list of tuples. So what is .values then? I mean, it spits out all the values. I have to ask the bear here. Alright, so map the chords to a new dictionary. Let's like explicitly break this down. So new chords. It's gonna be a dictionary. For each value is converted to plain text using convert.empty. So for key value in orgs dot items the value is converted to plain text. Value is converted to plain text using convert. Key should remain the same, so new orgs key is equal to the converted. So what triggers the conversion? I think that's where I'm stuck. Where each value is converted to plain text, map it. The key should remain the same. Use the items dictionary method to pass a list of tuples key values to the map. Create a function for map1 which changes the value of the tuple. So take a look at the formatters. The formatters functions do. Like, when would it not return? I think this is gonna be like if I don't want to block though. If something happens, and then else it's just gonna, I think, return just the value, but I don't know what the trigger is. trigger. Keep the markdown function. It can decorate a function with any number of string arguments, no matter if they're positional keywords or arts. It will run a decorated function but strip out any markdown symbols. Map the quarks to a new dictionary where each value is converted to plain text using the convert method. You should remain the same. Use the items dictionary message to pass at least duplicate pairs or map. Get a function map which changes the value of the item tuple of the convert MD text. How do I convert to string? Convert a value to a string in Python. Use string function is used. Okay. So if the value is a string, is there like I don't want value to equal string. I want it to be like, how do we check to see if a value is a string? Check to see if value is a string. Is instance? This instance function is most commonly used and efficient way to check if a variable is a string. Allows us to check if an object belongs to a specified tuple class. Shit, it's is instance. So object class, we want to put not list, we want to see if it's a string. The object is the values. Okay, if value So if is instance value is a string, then convert MD to text into the new Quarks dictionary. Otherwise, just return the Jesus. Okay. I think that's it. Right? The value is a string. The value isn't a string. Then just it equals the value. The dictionary equals the value. If value equals a string, then the new dictionary is the converted value. Okay. Return the result of the calling decorated function with the new arguments. Okay, so then we need to return just call this new args because I called the other one new quarks. So we need to return the result of calling the decorated function with the new arguments. How do I do that? Function to decorate. Just return funct. Okay, so can I write function to decorate? So it does the same thing. New args. New quarks. Like that. You failed. Converted empty text takes one positional argument, but two are given. The key and value in the dictionary. If the value is a string, convert this to map the course in a new dictionary where each value is converted to plain text using convert MT. The key should remain the same. Map must have at least two arguments. Wait, I can do it like this? My map doesn't have two arguments and my convert MD to text has too many arguments. Alright, Boots. See if I can fumble across the finish line here. Where are you? I see a few subtle issues in your implementation that we should address. When mapping over args, you're using star args. Oh. Which will unpack the tuple separate argument from map instead. So you want the map over just args. Typo. Dude, that's my my kryptonite is a typo. Distance below. You're using func to decorate in your wrapper, but the variable doesn't exist. The decorated function is passed as func. Oh. Up here. I was just copying the example. I was a little bit confused there. The if-else check for string types is not needed since convert empty text is designed to work on strings. The exercise mentions mapping chords, which is a cleaner approach. Map the chords using dictionary comprehension or map function. So I just need this. You think of a way to map the chords as well.
Oh, sisters, you so wise and true. When it's my time to go, won't you lay me down under granum crowns, and I'll be sleeping in the cold below, sleeping in the cold below.
It's not just like dict, map, convert, MD to text with chords. When you map over dictionary directly, you're only mapping over the keys, not the values, and convert empty specs a string input, not a key. According to the assignment, you need to use items method to get key value pairs. Create a function that changes the second element. Guide you through this.
So farewell with a kiss, then it's fast for the mist, till we're all sleeping in the cold.
Convert the args. We did that. We should write a new function. Define process chord tuple. Key value equals item. You see how we're using map and items method and the helper function? Yeah. I just didn't make another function. That was the issue. When I should have. For processing the tuple. I tried to like process the tuple in like a statement. I don't think that was right. Chord to item text, item tuple. key value item tuple, return key, and converted value. Right, and then converted quargs is equal to the map of the quarg item to text, quarg items, function and iterable. Convert that into a dictionary. Yeah, it's the same as the bear recommended. I didn't follow the instructions quite to the T there.
Decorators review. A Python decorator is just syntactic sugar for higher order functions. Syntactic sugar just means a more convenient syntax. Not all programming languages have built-in decorators, but most do support higher order functions and closures. Some of the famous functional languages like Haskell, Erlang, Clojure, Lisp do not have special syntax decorators, but they do have higher order functions and closures, meaning the decorator pattern can still be used. So if you understand those concepts, they will serve you well in many different languages.
Yeah, higher functions. Function decorators are not as often supported as plain higher order functions. True. Function carrying higher order functions and first class functions are unique to purely functional languages, unique to Python, unique to OOP languages, commonplace in most programming languages. Function carrying high order functions. High order functions is a pretty common denominator, and first class functions are commonplace in most programming language.
Configure plugin. Doc2Doc should be extensible to allow for third-party plugins. These plugins will be configurable. Assignment. Complete the configure plugin decorator function. It decorates a func that takes keyword arguments quargs, but the wrapper function it returns takes positional arguments args. The arguments passed to the wrapper will be a series of tuples, each a key value pair. Convert the args into a dictionary with the dict function. Get the result of passing this dictionary into the func as keyword arguments unpacked with the store operator. Return the result. Plugin config was configure backups, path/duplicates, prefix duplicaf. Plugin config, path./duplicates, prefix duplicate score, extension RTF.
All your adventures. That was good. Can you please take a picture? Sure.
Okay. Complete the configure plugin decorator function. It decorates a func that takes keyword arguments quargs, but the wrapper function it returns takes positional arguments args. The args arguments passed to the wrapper will be a series of tuples, which are a key value pair. Convert the args into a dictionary with the dict function. Okay. You getting dict? Dict. Dict args. These are quargs, right? Get the result of passing this dictionary into funct as keyword arguments unpacked with the ** operator. Yeah, like ours is 1 star, quargs is 2 star, so fong quargs. Pass it, okay. Oh. We have to make another function. Wrapper function. Key arguments, but the wrapper function, it returns the potential arguments, args. The argument passed the wrapper will be a series of tuples. So args. Convert the args into a dictionary. Yeah. Get the result of passing this dictionary into a funct. This keyword argument packed with the ** operator. Yeah. Turn the result. I like mine better because the quargs is like a dictionary.
Escape HTML. You can stack decorators and you can use currying with decorators. Def to uppercase func, def wrapper document, return func document upper return wrapper. Def get truncate length, def truncate func, def wrapper document, return func document length, return wrapper. Return truncate to uppercase get truncate 9. Currying. Def print input input, print input, print input, keep calm and carry on, prints keep calm. Observe that to uppercase wrapped get truncate 9 and get truncate 9 return truncate, which wrapped print input, then print input printed keep calm from keep calm and carry on. You might not know anything about HTML. That's fine. This challenge isn't about HTML directly. Just understand that it's a markup language like Markdown. Certain characters are interpreted as part of HTML tags. In order to show these characters without interpreting them, they must be encoded as escape sequences. TLR replace ECH. Doc2Doc needs a feature that can take care of encoding such characters for you. This is particularly helpful if you want to show raw HTML on a vanilla HTML web page. HTML even has a semantic pre-tag for designating pre-formatted text. Assignment. Complete the replacer function. It takes as input 2 strings, old and new, and returns a function replace. Replace takes an input function, decorated func, and returns a wrapper function. Wrapper takes as input a string text. It uses .replace string method to replace instances of old with new in the text. Then it returns the result of passing the modified text to the decorated func. Use a series of the replacer function to decorate tags called pre. Pass the following pairs of strings to these decorators to encode the escape sequences. Replace an with end, replace ant with when, replace strength with, replace space with.
Okay. Takes two input strings, old and new. Returns a function, replace. Okay. Replace takes the input function, decorated function. And returns a wrapper function. Okay. Wrapper takes the input, takes as input a string text. It uses .replace string method to replace instances of old with new in the text. So text dot replace. And then that's dot replace. Old, new. Literally, it's old and new. Old and new. Okay. What was the third variable? Count minus 1. Count is not specified or -1, then all concurrences are replaced. Okay. Then it returns the result of passing the modified text to the decorated func. Decorated func. Modified text. Use a series of replacer function. Decorate. Tag pre. Pass the following pairs of strings to these decorators to encode escape sequences. Return. Wrapper. Return. Replace. So then, at replacer, and then I just input ampersand with ampersand amp semicolon. I copy these. Oh. I don't think it's width though, I think it's just comma. That.
Life's
A series of replacer function to decorate tag. Wait.
Effect in the cause, curtain falls, but hold your applause. Squirm, squirm, for now down here come the claw.
Oh, this. Yeah, they just put this into here.
Fools, how hard you have fought. Brave, but it's all been for naught. True souls that couldn't be bought. Doomed, detected, and caught.
Uru. Elru?
LRU cache. LRU cache from the FuncTools module is an example of a decorator and an example of memoization. LRU cache memoizes the inputs and outputs of the decorated function in a size-restricted dictionary. It speeds up repeated calls to a slow function with the same inputs. For instance, if the function reads from disk, makes network requests, or requires a lot of computation, and it is used repeatedly with the same inputs. Here's an example from the Python documentation that perfectly illustrates how and why to use the LRU cache decorator. From FuncTools, import LRU cache, def factorial rx, if x equals 0, return 1, else, return x, factorial r x minus 1. Factorial O previously cached result makes 11 recursive calls. Factorial R5 just looks up cached value result. Factorial R12 makes 2 new recursive calls. The other 11 are cached mul. Since the factorial function is recursive and the inputs are sequential numbers, it's called repeatedly with the same inputs. Without the cache, the function would be called 30 times. With LRU cache, the function is only called 13 times. While you don't often need to compute factorials, this example ties together how to use a decorator and memoization and recursion. Assignment. The creator of Doc2Doc is a huge fan of palindromes for some nerdy reason. Add a feature to check if a word is a palindrome. Import the LRU cache function from the FuncTools module. Use it to decorate the incomplete isPalindrome function. Complete the isPalindrome function. It takes as input a word string and returns true if the word is a palindrome, such as race car, or false otherwise. Try to use recursion. Check the outer characters first. Then move inwards until you reach the base case, or find the word is not a palindrome.
No more deals, it's over. The final act, you're doomed. No more grace, it's over. This house of hope. You're doomed.
Import LRU cache function from FuncTools. Use a decorative to complete isPalindrome function. Complete is palindrome's same forward and backwards. A man, a plan, a canal, Panama. Try to use recursion. Okay. Check the outer character first, then move inwards into the basic case where it's not a palindrome. Alright, so the base case is one letter. A one-letter word is a palindrome. Right? So if length of word is equals 1. Return true for palindrome. If the first letter in the string, so word 0 position,
Doomed, detected, and caught.
so if word 0 in the first position equals the last letter, which is -1. Turn true. Else false. And then we need to recurse through is palindrome. So we would have to subtract one from the outside, one from the inside. Letters, the starting position for the next loop would have to be 1. The beginning is inclusive, the outside is exclusive. So we would need to be if it's inclusive, we need to start in the second position, so we need to start at 1. And if the last number is exclusive, that would be -1. Right? Because we're subtracting another one. So I think it's -1. It could be wrong. Because it's gonna take... So if it was like race car, it's processed the R's and spat out true. Right? So the first letter and the last letter are the same. Then it's going to take A to A. Well, A to A is now the 0 to last position. So we want to start... Or no, the inputted word, we want to remove the first letter, so that'd be A. And the last letter, which is R. Right. Then we go, then that's A to A. And it goes through the loop again. So now A to A is our ending, and then it's gonna take the first letter and the last letter off again and keep going. I guess 1 or 0, right? 1 or 0. Oh wait, what? I had 7 passes, and this came back false. There's some fringe thing that I'm not getting. Some fringe case. Max size is 128, comma, type false. If max size is set to none, the algorithm feature is disabled. The cache can grow without bound. Max size equals none. I have to set that. What was the other one? Typed. Specifically, only the functional's immediate arguments rather than their components. Treated as distinct calls with distinct results. In contrast, the tuple argument answer decimal 42 and answer 42 treated as equivalent. I guess I do have to set max size equal to none. Something bricked. String index out of range. If word 0 equals word minus 1. Oh, when you input nothing. String index is out of range. So do I just do doesn't equal? For like a null case? Oh, I fucked it up now. So the problems when we put null case in, nothing. It gets caught up on this. The word in the first position of the word is equal to the last position. Return true, but there's nothing there. word equals an empty string. Return. True? There we go. The length of word is less than 2, return true. Ah, that makes sense. First word, last. First, last. If first doesn't equal last, return false. Okay. How did mine pass it? I didn't return this. I'm like, I'm not gonna rewrite it for the null case. I'll just throw this in. Ooh, we're almost done. 5 more. Plus 2 bonuses.
Sum types. Remember when I said pure functions are my favorite part of functional programming? Well, sum types are a close second. A sum type is the opposite of a product type. This Python object is an example of a product type. Man.studiesfinance equals true. Man.has trust fund equals false. The total number of combinations a man can have is 4. The product of 2.
Sorry, I'm not listening. Alright.
2. Sum types. Remember when I said pure functions are my favorite part of functional programming? Well, sum types are a close second. A sum type is the opposite of a product type. This Python object is an example of a product type. Man.studiesfinance equals true. Man.has trust fund equals false. The total number of combinations a man can have is 4. The product of 2. Studies finance has trust fund. True? 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 False. True. False, false. If we add a third attribute, perhaps a has blue eyes boolean, the total number of possibilities multiplies again to 8. Studies finance has trust fund, has blue eyes. True, 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 false, true, false, true. Dateable, undateable. 3 types of people that. But let's pretend that we live in a world where there are really only 3 types of people that our program cares about. Dateable, undateable, maybe dateable. We can reduce the number of cases our code needs to handle by using a, admittedly fake Pythonic sum type with only 3 possible types. Class person, def init self-name, self.name equals name. Class dateable person, pass class maybe dateable person, pass class undateable person, pass var. Then we can use the isInstance built-in function to check if a person is an instance of one of the subclasses. It's a clunky way to represent sum types, but hey, it's Python. Def respond to text, guy at bar. If isInstance guy at bar dateable, return, hey, guy at bar.name, I'd love to go out with you. Elif isInstance guy at bar may be dateable, return hey guy at bar.name, I'm busy, but let's hang out sometime later. Elif isInstance guy at bar undateable, return have you tried being rich? Else, raise value error, invalid person type. Sum types. As opposed to product types.
That's me. Well, outside of the not dateable scope, I'm a invalid person type.
Which can have many, often infinite combinations. Sum types have a fixed number of possible values. To be clear, Python doesn't really support sum types. we have to use a workaround and invent our own little system and enforce it ourselves. Assignment. Whenever a document is passed by doc2doc, it can either succeed or fail. In functional programming, we often represent errors as data, e.g. the parseError class, rather than by raising exceptions, because exceptions are side effects. This isn't standard Python practice, but it's useful to understand from an FP perspective. Complete the passed and parseError subclasses. Passed represents success. It should accept a doc name string and a text string and save them as properties of the same name. ParseError represents failure. It should accept a doc name string and an air string and save them as properties of the same name. The test suite uses the isInstance function to see if an error occurred based on the class type.
Alright, so the init stuff is just self.doc name equals and self.text equals. And this one's gonna be self.doc name equals self.er. Parse represents success. It should accept a doc name string, a text string, and save them as properties of the same name. Doc name? Text? Parse error represents failure. It should accept doc name and error string and save them as properties of the same name. Doc name? Error? The test suite uses isInstance function to see if the error occurred based on the class type. That was easy. Oh, you know what it is? Because we were doing the init stuff with what do you call it? Whenever I see init, it reminds me of like parent classes. Oops. Just trying to hit back down here.
Enums are one of the best things to happen to programming, and that's including the release of the best operating system of all time, Windows Vista. But before we talk about enums, let's brush up on a little bit of category theory. And despite the word theory being added to scare non-academics, it's really not too bad. In programming, types are how we categorize things. For example, this partner class contains two variables, both of which are Boolean types. So the partner type actually contains other types. And this is common when working with collection types like lists, tuples, and classes. The interesting thing about this partner class is that it really has four possible combinations of values. Studies finance can be true, has trust fund also true. Studies finance true, has trust fund false. Studies finance false, has trust fund true. Studies finance false, has trust fund false. And that seems manageable, but what happens if we add a third field? Well, if it's also a Boolean, then the number of possibilities actually jumps up to 8, because we have to multiply 4 by the available combinations again, which is 2, getting 8 possible total combinations.
Or if you're degenerate better, like me, this is called a trifecta box in horse racing.
If we add another, we get 16. And if we go up to 5, then we get a total number of 32 combinations. And if we add a string into the mix, instead
I hit a fucking trifecta box at the Kentucky Derby while I was there. And I bet, what did I bet? It was $13 per box. It was like all the money I had. So it was 13 times 9. So I bet $117 for the trifecta box because it's the permutation of all three horses. So it's like 123, 132, 213, etc., and so on. And that paid out. So it's $13 times. What did I end up with? I ended up with like 1,500. No. That paid out 115 to 1.
Instead of a Boolean, then the number of total possible values essentially goes up to infinity, because a string can contain any number of combinations of characters. Now, this is where the term product type and sum type come into play. They're also sometimes referred to as algebraic data types, just to scare the non-PhDs. The partner class is a product type because the total number of possible combinations of values is the product of the number of fields, right? 2 times 2 times 2 times 2 times 2, however many Boolean fields we had in there. But product types are very interesting. Almost everything is a product type by default.
So if it's not a Boolean value, but it's, say, like a range of numbers, you're no longer squaring it. You would be raising it to whatever that. So like if it's a series of numbers 1 through 4, integers, you'd have to raise it to the 4th degree instead of the 2nd degree.
Lists, tuples, and classes with, a number of properties. And the problem is that product types result in many possibilities. And even primitive types like strings and integers have the same problem. When you have a string type, you don't know if that string value contains the entire text of the novel Moby Dick, or the string Hello World, or the empty string. There's so many possible combinations that could be stored in that type. And that makes them hard to work with, right? When you write a function that accepts one of those types as a parameter, you have endless if-else statements and switch cases and fallbacks to handle all of the different possibilities that could arise when your function is called with different values. That's where sum types come into play. They're just types where the number of possibilities is limited to a finite set. A Boolean is a good example of a sum type. It has 2 possibilities, true and false. When you're working with a Boolean, all you have to think about is whether this variable is true or false. Okay, so now we can finally talk about enums. Enums are another sum type, like a Boolean, and really I like to think about them as kind of extended Booleans. For example, let's say we want to write a button class, and in this button class, we want to specify that it can be one of 3 colors. We could have the button's constructor accept just a string to define which color it's going to be. And we'd accept either the string red, the string green, or the string blue. Now, the problem is that our button class now needs to take into account that whoever's creating a new button could pass in any string, right? They could pass in the string teal, or they could just pass in a misspelled blue, and we need to handle both of those cases. The better option is to use an enum. And at least in Python, the way you can define.
What's great is that I love the autocorrect because I'm terrible at spelling. So like, whenever I type something into the field on a computer, most of the time, it's written well enough that it understands what I'm trying to fucking say.
An enum is using the enum package. You pass in the name of the enum. In our case, we'll use color. And then the possible values that are valid in this new type. So in our case, red, green, and blue. Now in our code, if we use color.red, it will work. It will resolve to the color red. And as far as the color type is concerned, everything will work smoothly. But if we try to use a color that was not specified when we created the color type, like teal, the Python interpreter itself will actually throw an error. So now the language itself will raise an exception if we ever try to use the wrong value. And that means that in all of our code, we no longer need to have all of these if-else statements checking and making sure that the variable maps to a valid value, right? There might be 10 different places in code that have to check the value, and we don't want to rewrite all that code. In a language like Python, the interpreter will yell at us when we run the code if we ever use an invalid value in an enum type. But in statically typed languages, like a lot of the compiled languages like Go or TypeScript or C, we'd actually get the errors either at compile time or even better, right in our editor telling us that those values are not allowed for that type. That said, enums are still useful even in a language like Python. Python's not statically typed, so it does mean we'll have to actually run the code to see the type errors, but at least the valid values, red, green, and blue, are defined when we create the enum type. So there's a single place to reference so we as developers can see what colors are valid types, and we won't have to keep redefining it every time we check the value.
Enums. Doing the admittedly weird class and IceInstance thing works, but it turns out there's a better way in some cases. If you're trying to represent a fixed set of values, but not store additional data within them, enums are the way to go. Let's say we have a color variable that we want to restrict to only 3 possible values: red, green, blue. We could use a plain old string to represent these values, but that's annoying because we have to remember all the valid values and defensively check for invalid ones all over our codebase. Instead, we can use an enum. From enum import enum color quotes enum color red grew print color.red. This works, prints color.red, print color.teal. This raises an exception. Now color is a sum type, at least as close as we can get in Python. There are a few benefits. A color can only be red, green, or blue. If you try to use color.teal, Python raises an exception. There is a central place to see the valid values for a color. Each color has a name, e.g. color.red, and a value, e.g. 1. The value is an integer and is used under the hood instead of the name. Integers take up less memory than strings, which helps with performance. Assignment. Create an enum called doctype with values, pdf, txt, docx, md, html tip. Don't forget to import the enum class from the enum module.
All right, so from enum, import enum. Create an enum called doctype with values. Class? What was the previous example? Class. So class enum. An enum called doctype. Doctype? Enum. Enum with values. PDF. TXT. Docx. System exit. What the fuck? Oh. Not import, name, enumerate. PDF is not defined. Oh, is it like equals the string PDF? Docx. Like that? Okay, cool.
Sum types. Unfortunately, Python does not support sum types as well as some of the other statically typed languages. Python does not enforce your types before your code runs. That's why we need this line here to raise an exception if a color is invalid. Def color to hex color. If color.green, return ff ring. If color.blue, return haro 0 f. If color.red, return ff 0 ru. Handle the case where the color is invalid. Raise exception, unknown color. In a language like Rust, we could write the same thing like this. fn color to hex color color. Matter string, match color. Color green 0 of ff to string. Color blue 0 ff to string. Color red ff 0 grow to string. Notice how there isn't any case for an unknown value. That's because the Rust code will fail to compile, a step that happens before the code runs at all, if the color is a different value. This static enforcement is a huge benefit of sum types, and it's a shame we can't get that in Python.
Language does not support proper sum types, Python. Why are sum types useful? You have to run your code to see if you'll handle all possible cases. You can know before you run your code that you've handled all possible cases. Ensure that your variables can hold any type of variable. You have to run your code to see if you can handle all possible cases. You can know before you run your code that you handle all possible cases.
Match. Let's take another look at our example enum from the previous lesson. Color equals enum color red, green, blue. Working with enums. Python has a match statement that tends to be a lot cleaner than a series of if-else-elif statements when we're working with a fixed set of possible values, like a sum type, or more specifically an enum. Def get hex color, match color, case color.red, return hef case color.green, return error 0ff, case color.blue, return tap 000 ff, default case, invalid color, case score, return fff. If you have two values to match, you can use a tuple. Def get hex, color shade, case color.red light, return hff case color red shade dark, return a00, return green a light, return 2 vfla, return 00 a, return ff, case shadark, return have 0 a default case, invalid combination, case skirt terhff. The value we want to compare is set after the match keyword, which is then compared against different cases patterns. If a match is found, the code in the block is executed. Assignment: complete the convert format function. Using the enum doc format, it should support 3 types of conversions. From MD to HTML, assume the content is a single H1 tag in Markdown syntax. It's a single string representing a line. Replace the leading tag with an H1 and add AH1 to the end. This is a heading. This is a heading to PDF. Simply add a PDF tag to the beginning and end of the content. Notice the spaces between PDF tags and the content. This is some text. This is some text. From HTML to MD, replace any H1 tags with hack and remove any H1 tags. H1, this is a heading, this is a heading. Any other conversion. If the input format is invalid, raise an exception with the string invalid type.
Alright. This seems pretty simple to go through, but I think my brain's cooked for today. So, I think I'm cooked. Maybe I need to drink more water. Maybe that's the issue. But that's going to be it for me this week for Boot.Dev. I'll be back on Monday. We'll do another 4 hours. Sorry if my fucking mic wasn't working in the first. I should have checked it initially. But we have like 3 more questions to finish up here. And then we're going to be moving on to build a static site generator. That's kind of cool. But yeah. I might be on later playing some Kingdom Come Deliverance. Have a good night, or have a good evening. Stay safe out there. If you do dumb shit, do one dumb shit thing at a time so you don't get caught. And I'll see you guys on the next one. Bye.